Okay, friends, before we start today, I want you to make sure you get a highlighter or a marker or something that you can mark up your notes with a different color. Because today we're talking about a lot of identities, and we're going to use these identities to kind of prove different things within trigonometry. And so understanding and seeing these patterns and understanding how to derive these different identities is going to help you with all the problems. So grab a marker, grab a highlighter, something as we go through these notes. All right, here it goes. Hang on. First of all, I want you to look at these identities right here. This is sine squared x and cosine squared x. Now they are written this way. You will always see them this way. But what they mean for you and for calculator purposes is that sine of x squared. Okay, it really is saying we're going to take the sine of x and we're going to square that entire value, whatever it is. We just write it sine squared x. Just take it as the way I say it. Okay, take it as the way I say it. Because if we look over here at these examples over here, if we had said cosine x squared, that really just means square the x term and then take the cosine of it. Or square the x term and take the sine of it. In reality, those give us two very, very, very different values. So here's a great example. Say x is 9 degrees. If we take the cosine squared of x, that means take the cosine of 9 degrees and square the entire thing, which results in approximately 0.9755, if you want to be precise. Okay? If we take the cosine of x squared, what that says is take the cosine of 9 degrees squared. In essence, the cosine of 81 degrees, which gives us, as you can see, a very, very, very different value. It is no longer 0.97, it's 0.15. Okay, so it's a big difference. So notice the difference in the setup and the eventual answer. Okay, this is very important for this entire lesson today. All right, so let's look at example number 1. Here we go right here. And we're going to play with this one, and you're going to notice, as I put over there on the left, you're going to notice a pattern. But I want to work through it with you first. So let's go ahead and do that. We're going to work through this example number 1. So example number 1 is saying, so have your calculators with you, determine the sine squared x, the cosine squared x, and the sine squared x plus the cosine squared x for each value of x. So I'm going to do these down here because this is going to get a little bit big. If I do, I'm try to get them all in that little white space. So I'm going to do them down here. So here is A. All right, I'm not going to write in blue because that's going to hurt my eyes if I end up doing that too long. All right, so there's A. Here we go. X is equal to 30 degrees. So the first thing it says is find sine squared of x. And in this case, it's 30 degrees. So remember, when we put that in the calculator, please remember that that looks like sine of 30 squared. That's how you have to type it in, oops, as I dropped my calculator, into your calculator. So parentheses, sine 30 squared, enter. And that gives you 0.25. Okay, so that's sine squared of 30. Now I want us to do the cosine squared of 30. Remembering how to put it into your calculator, putting in parentheses cosine 30 squared. Okay, so parenthesis cosine 30 squared gives you 0.75. Now the third component that it wanted you to do, it said determine sine squared x, cosine squared x, and sine squared x plus cosine squared x. So now we have to add sine squared of 30, oops, that's a 30, plus cosine squared of 30. Well, sine squared of 30 was 0.25, plus cosine squared of 30 was 0.75. 0.25 plus 0.75 is 1. Can we remember that? So I'm going to make some notes up here. So I'm going to put S is 0.25. That's a 2. I'm going to put C is 0.75. And I'm going to put the addition of those two is 1. All right. So let's do the next bit. I'm going to erase this fun stuff. We'll do part B. Part B, we're going to do the exact same thing, except in this case, we're going to use 45 degrees. And I hope you're kind of remembering and thinking back to those special right triangles. 30, 60, 90 was for A, and B is your 45, 45, 90. All right, so let's look at B. Let's look at the sine squared of 45. Again, remembering to put it in your calculator like parentheses, sine 45, close parentheses, squared. Whoa, 0.5. Okay, well, let's try the cosine squared of 45. Now, I guarantee you 99% of you are going to put that in your calculator, but I hope there's a 1% of you that is thinking to yourself, wait, okay, if a 45 degree triangle, 45, 90 degree triangle, I know that this is x and this is x and this is x squared to 2. And I know that sine is some old horse of this angle down here, right? If I'm looking at this angle down here, some old horse, so it's x over the hypotenuse, x over 2. And then I hope you are realizing that cosine is caught another horse, the adjacent over the hypotenuse, which is x over x squared to 2. That's the exact same thing. So if you put it in a calculator and you put parentheses, cosine 45 squared, you're going to see that it also ends up to be 0.5. And then last but not least, we have sine squared of 45 plus the cosine squared of 45. Oh, that's 0.5 plus 0.5, and that is 1. So again, I'm going to write that up here. The sine, oops. Shouldn't have done that. The sine, let me erase that real quick. Get rid of that yuckies. Okay, the sine is 0.5. The cosine is 0.5. And the addition of those two is 1. Okay, are we noticing a pattern here? So I'm going to erase this real quick. Get rid of this. Ha-cha-cha. Okay. Erase. And we're going to do the last one. We're going to do 75. Okay, so we're going to use the cosine and sine squared of 75. Okay, so here we go. Oh, sine squared of 75. I'm going to use my calculator again. Hopefully you're seeing now how to do it, and I'm not having to say parentheses sine 75 close parentheses squared. But if I did, you just heard me say it. 0.9330. We'll round it off there. Now, I need to do the cosine squared of 75. Again, calculator. I didn't say it that time. Which becomes 0.0669. Now, if we add them together, we get sine squared 75 plus cosine squared 75 equals 0.9330 plus 0.669. Does anybody else notice that that becomes 999? Right? Oop, I left out my 0 here. Sorry. 0.9999. In essence, That's 1. Now, if you wanted to type it into your calculator, which I encourage you all to do, type it in just like this, except using the parentheses notation, because that's how you have to type it in to your calculator. So type in sine of 75 squared plus cosine of 75 squared. And if you type it in correctly and hit enter, you will get 1. So look up here. This gives me the sine is 0.9330. The cosine was 0.0669. The addition of those two essentially is 1. Do you notice a pattern? I asked you this at the beginning. Are you noticing a pattern? Repeatedly subbing different angle measurements confirm that sine x squared, or sine squared x, plus cosine squared x is equal to 1. So if we have something that is true for every value of the variable, every single value of a variable, if it is true for that, it gives us something we call an identity. And here we are. This is your Pythagorean identity. Your Pythagorean identity says for any angle x, sine squared x plus cosine squared x is equal to 1. This proof right here is great. Really, honest to goodness, it's great. And I know all of you guys are like, no, proofs are great. This is a great proof because we're going to use this. We're going to use these kind of representations of sines with a over c and cosine is b over c later on in the lesson. And I want you to feel comfortable with that. I want you to get used to seeing, your sine of x written as the opposite value over the hypotenuse. And I want you to see and get comfortable with the cosine of x is written as the adjacent over the hypotenuse values. So what they did here was then they just solved these. If we were going to solve for a, we would multiply both sides by c. And if we were going to solve for b, we would multiply both sides by c. Then we would look, Pythagorean theorem is a squared plus b squared equals c squared. So the fun thing that they did right here is they substituted. Instead of a, they substituted c times sine squared of x. And instead of b, they substituted in c cosine squared of x is equal to c squared. Then they just kind of distributed the square like normal. So that would be c squared plus sine squared x plus c squared cosine squared x is equal to c squared. Then you get to divide everything by c squared. So if I divided everything by c squared right here, the c squared over c squared reduces down to 1, and the c squareds go away in front of your sine squared and cosine squared. It's a great proof. It's a great proof, and I really encourage you to hit pause on this lovely presentation and really look at this identity. It really is important for you to see that. Okay? All right, so we're going to get rid of that. Okay, so remember when I told you I wanted you to get comfortable with looking at sine as a over c and cosine as b over c? Well, that's what I want to do with example number 2. So example number 2 is asking us to use this triangle ABC to prove that the tangent of x is really the sine of x over the cosine of x. So I want us to, even before we begin, I want us to designate what is the sine of x. So over here, I want us to say, all right, the sine of x, this little area here, remember, some old horse, the sine of x is a over c. Okay? And then I want us to talk about the cosine of x. The cosine of x is b over c. Okay? So far, so good? So now I want us to plug that in and use some substitution. Hopefully you're remembering substitution. Instead of writing sine of x right there, I want you to write what sine of x is equal to, a over c. And instead of writing that the cosine of x is b over c, put it right down there, b over c. And what I mean by that, watch right here. I want you to write that the tangent of x is equal to the sine of x. So that sine of x, instead of writing sine of x, I'm going to write a over c. And then instead of writing cosine of x, I'm going to write b over c. So now let's please remember back into the olden days of fractions. That's a fraction divided by a fraction. In reality, friends, what that says is the tangent of x is equal to a over c divided by b over c. Right? That's what a fraction is. Right? We're dividing the numerator by the denominator. Now, how do we divide fractions? Copy, dot, flip, or keep it, change it, flip it. Oh, look what fun thing happens right here. My c's cancel out. So the tangent of x is really equal to, these cancel to 1, a over b. Now, let's look at if we were to take the tangent of this value x right up here. So if I were to take the tangent of x, remember, tangent of x is taking oats away, the opposite, a over the adjacent, which is b. The tangent is the opposite over the adjacent. So the leap or the logical progression is that yes, the tangent of x is equal to the sine of x over the cosine of x. So remember that marker or highlighter or different color pen that I had you get? I want you to take that and I want you to color that. I want you to make it bold. I want you to put 17 stars next to it. I want you to write it on a separate sheet of paper, whatever you want to do, but you need to have within your trigonomic arsenal, your arsenal is all the tools you have to work with, in your geometric, trigonometric arsenal, I want you to have this formula. All right, so what, Peacock? Why do we need that? Well, I'm going to show you. Let's get rid of this stuff. Whoop, get rid of it. Oh, by the way, while I'm moving stuff around, my husband told me I said trigonometric wrong, and I think it's because I'm Southern, and I kind of left out syllables. He said, it's trigonometric. And I said, oh, like an Italian restaurant. We'll say it, trigonometric. So that's my joke with my husband now, is that I'm saying trigonometric all the time, and he thinks I'm an idiot. But my whole life, I've only said trigonometric. I don't know. We didn't learn grammar that well at my high school or elementary school. Anyway, so before I keep going, all this stuff we're working with all the different properties. Okay, so we worked with that transitive property right there. Okay, so since the transitive property of equality guarantees that the initial expression is equal to the final expression. So kind of we had an if, and a then. I didn't write it out very clearly, but I'll write it out real clearly right here. I did all my notes, so I apologize. Well, I don't know why that happens. If the tangent of x is equal to a over b, and this is what we found, so this is the one that we found in our manipulation of that sine x over cosine x, and from the triangle the tangent of x is equal to a over b, then we can prove that the tangent of x is equal to the sine of x over the cosine of x. Okay, that's what this is talking about right there. This is saying If once we manipulated that formula and we broke it all the way down into that first step and said tangent of x was a over b, and then when we looked at the triangle, we were able to look at the triangle and visually see that the tangent of x was a over b, then, if and then, we can surmise that the tangent of x is the sine over cosine. And I made you star that, I made you highlight it, I made you put a little marker on it. Write it on a separate sheet of paper. If you still haven't done it, do it now, okay? So that's really important for all this. We are going to start talking about something called secants, cosecants, and cotangents. These are all reciprocals of the regular trigonometric, as I have now been schooled on how to say it, trigonometric ratios, cosine, sine, and tangent, okay? All right, so I'm going to come back to this little guy. So I'm just going to kind of make him a little bit little, but I'm going to come back to him in a second. But I want you to I want to show you these basic trigonometric ratios. Here we are. Y'all are going to say that all day, I promise you. Here's another thing that I need you to star. I need you to highlight it. I need you to write on a separate sheet of paper. I need you to call it your best friend. I need you to bring your mom into the room and show her what you learned. You need to have these written down somewhere. These are important. These are the reciprocal trigonometric ratios. Secant is equal to 1 over the cosine. It's basically flipping over that fraction. It's the reciprocal. Remember when we talk about cosine, we talk about cot, another horse. My pen's not working for some reason. Another horse. So it's the adjacent over the hypotenuse. Well, look what we did right here. We flipped it over. We said, nope, we're going to flip it over. It's the hypotenuse over the adjacent. That is the secant. It's the reciprocal of the cosine. So now, same thing with the cosecant. The cosecant is the reciprocal of sine. It's, instead of some old horse, S-O-H, we're going to flip that over, and it's going to be the hypotenuse over the opposite. So here it is. That's the reciprocal. It's cosecant. Again, write this down, put it on a separate sheet of paper, put it somewhere where you can see it, highlight it, mark it, circle it, star it, anything you want to do. Then cotangent is the inverse or the reciprocal of tangent. So if tangent is opposite over adjacent, cotangent is adjacent over opposite. Okay, and that's our last one right down there. All right, so you got those written down? You have to have them somewhere. Okay, write them. I'm going to give you a couple more seconds. Highlight, write, look at them, write them on a separate sheet of paper. Then we'll get rid of it. There it goes. All of you. Get rid of all of you. All right, so here comes example number 3. Whoop, whoop. There we go. Example number 3 says, prove that the sine of x times the secant of x is equal to the tangent of x. You guys thought you were done with proofs for the year, but these are informal proofs. So don't freak out about them. They're informal proofs. So let's look. We know sine x. We have been dealing with sine x. We've had sine x for a couple sections now. Secant is different. Go back to your notes right up above you and look. You started. Secant is 1 over cosine. Oh, okay, well, let's replace secant of x as 1 over the cosine of x is equal to the tangent x. Now, please remember that this sine x is a fraction, and please remember how to multiply fractions. We multiply across the top and across the bottom. So we have the sine of x over the cosine of x is equal to the tangent of x. Oh, excuse me, didn't you mark that somewhere? Didn't you put that somewhere? Didn't you write, star, highlight, circle that sine x over cosine x is the tangent of x? So you then just proved that sine times the sine of x times the secant of x is equal to the tangent of x. You have proved it. Okay? So it's not your 2-column proof, it's an informal proof. But remember earlier, or when we were looking at that big paragraph, and I said, you're going to want this, you're going to want this, you're going to want this. So look right here, look down in the bottom. Here's some other things we have down at the bottom. Expressing all trigonometric ratios in terms of sine and cosine frequently simplifies the verification of an identity, noting that cotangent is 1 over tangent, and applying the quotient identity that tangent of sine x over cosine x leads to the second quotient identity, cotangent of x is, well, the reciprocal of the tangent of x. It's the reciprocal. Flip it over. It's the cosine of x over the sine of x. Okay, maybe we should star this, and maybe we should write this down, and maybe we should highlight this. Maybe. It's on there for a reason. Okay, reciprocals. These are reciprocal ratios. All right. So Peacock, what we're going to do now. All right, so I'll tell you what we're going to do. We're going to use example number 4, and we're going to prove that 1 plus the cosine of x times 1 minus the cosine of x is equal to the sine squared of x. So this looks like something you probably did in Algebra 1. First, outer, inner, last. Remember that? First, 1 times 1 is 1. Outer, 1 times negative cosine x is negative cosine x. Inner, 1 times cosine x is cosine x. Last, cosine x times negative cosine x is negative cosine squared x. Okay, because remember, it's a cosine of x squared, because you're multiplying it by itself twice, but I can write it this way, is equal to sine squared of x. All right. Well, let's get rid of some stuff we don't need. We got a negative cosine x and a positive cosine x. Those go away. Oh, look what I'm left with. 1 minus the cosine squared x is equal to the sine squared x. Do you remember back at the very, very beginning that trigonometric great identity that we had at the very beginning, and it said sine squared x plus cosine squared x is equal to 1? Isn't that this? 1 is equal to the sine squared x plus the cosine squared x. So we did it. We proved it. We proved because that 1 minus the cosine squared x, so if we took this trigonometric identity right here and we solved it for sine, by subtracting cosine squared x. So if we subtract that cosine from both sides, or that cosine squared x, we get 1 minus cosine squared x. And that is the sine squared of x. So, basically all that's doing right there is that, and it's all proved that it worked out perfectly. Okay? So let's get rid of this. And let's pull this guy in for example number 5. It's all about some proofs here today, friends. All about some proofs. But don't freak out. They're not hard proofs. So let's do it again. Let's prove that the cotangent squared of x plus 1 is equal to the cosecant squared of x. So before we start looking at this, I want to kind of refresh us what cotangent was, okay? Cotangent squared x is really equal to 1 over, that's a 1 over the tangent squared x. Remember, that was one of those identities. I told you to circle, I told you to star, I told you to look at it. It's right there. So now what I want to do is then kind of look at what tangent squared x was. Okay, so now I want you to kind of hold with me with this logic. I want us to kind of now replace this tangent squared x. Okay, so instead of tangent squared x, I want us to write 1 over, remember tangent squared x is sine squared x over cosine squared x. Remember that? Now I want us, so this is still cotangent of x, haven't done anything squared, haven't done anything there, so I still have cotangent squared x. Now I want to get rid of that. Well, remember, copy dot flip, so I'm really going to take 1 over 1 and multiply by cosine squared x over sine squared x. Cosine squared x over sine squared x. So the cotangent squared x is really the reciprocal of tangent squared x, which is cosine squared x over sine squared x. So now instead of up here in this problem up here, instead of writing the cotangent squared x, I'm going to substitute in this guy right here, cosine squared x over sine squared x plus 1. Okay, is equal to cosecant squared x. Now, I want us to kind of replace this 1. I want us to replace this 1. Remember, I can replace this 1 with anything I want to replace it with, can't I? I can. So, what I mean by that is I'm going to replace it with, I'm actually just going to erase it, but you guys can rewrite it. I'm going to put it plus sine squared x over sine squared x. Oh, look at that. There we go. So now I have a common denominator of, oh, still on my eraser, of sine squared x. That's my common denominator. And look at my numerator. My numerator is cosine squared x plus sine squared x is equal to cosecant squared x. Well, look at that blue part. That's cosine squared x plus sine squared x. What is that equal to? You better all just said 1. So 1 over sine squared x is equal to the cosecant squared x. And if you look back in the trigonometric identities, you have just proved that the cosecant of some angle x is equal to 1 over the sine squared of that same angle x. Okay, this is not easy, but if you've kind of written down everything and highlighted it and starred it and circled it, you should have no problems working through 1 through 23 odd. Okay, join me in class for questions. Okay, all right, y'all have a great one.